Assalamualaikum and welcome to the 19th video in our second chapter, that is the 5th video of this chapter called as Algebraic expressions, and we'll see a new topic today called as coefficients and one more topic called as like terms and unlike terms. Let us begin by understanding what are coefficients. Let me give some examples first so that it can be clear to you. Example, if I have something like 12x, okay? So for 12x, how to identify the coefficients? So if I tell you coefficient of 12 is, so leaving 12, whatever is remaining, that will be called as coefficient of 12. So if I ask you to find out coefficient of 12, what is remaining leaving 12? X. So the coefficient of 12 is x. If I tell you coefficient of x is, now if I ask you what is the coefficient of x, what you should do, you should leave x and see whatever is remaining. So if you leave x and see what is remaining there, so if you leave x, only 12 will be remaining. So the coefficient of x is 12. That is the meaning of coefficient. So if you are asked to find out the coefficient of something, so leaving that, whatever is remaining, that will be the coefficient. Little advanced example, if I take 8xyz, okay? So coefficient of 8. What is the coefficient of 8? That means leaving 8, what all is remaining? xyz. So the coefficient of 8 is xyz. Coefficient of x. That means leaving x, whatever is remaining, that will become the coefficient of x. So leave x. So if you remove x, what is remaining? 8 is remaining, y is remaining and z is remaining. So the coefficient of x is 8yz. Okay. So coefficient of y. What will be the coefficient of y? That means leaving y, whatever is remaining. What is remaining? 8 is remaining, x is remaining and z is remaining. So 8xz. So the coefficient of y is 8xz. Similarly, what will be the coefficient of z? That means leaving z, what is remaining? 8xy. Okay. So this is called as coefficients. And if you are asked to find out a coefficient of one particular value, then leaving that value, whatever is remaining, that will be called as coefficient. So like this, try coefficient for every term, for every variable or constant. Minus 4xy, 2abc and 9 by 2 pq. So this is your homework. So what I want you to do is, I want you to write the coefficient of each. The example I will give, coefficient of minus 4. Coefficient of minus 4 is xy, because xy is remaining. Next you will write coefficient of x. That means if you remove x, what is remaining? Minus 4y. Lastly, coefficient of y. Coefficient of y will be minus 4x. So coefficient of any one particular value will be leaving that remaining whatever is there in the question. So like that, please follow this kind of procedure and try to write down coefficients. It will help you to do the problems later on in a much better way. So learning coefficients is important. Try to find the coefficient of each value in the given question. Okay. So I hope you have understood. If not, let me know on the Google Classroom app. I will try to clarify your doubts. And otherwise, rewind the video and check the explanation from starting so that it will be clear to you. We'll move on to the next topic. Like terms and unlike terms. So if we have algebraic expressions, many algebraic expressions, like we saw first exercise where so many algebraic expressions were mixed up, we were supposed to tell whether they are constants and variables. Next exercise we saw so many algebraic expressions mixed up and we were supposed to tell whether they are monomials, binomials or trinomials. Let us suppose we have a lot of algebraic expressions mixed up like that, and we should tell them now whether they are like terms or unlike terms. So what are like terms? So all the algebraic expressions that have same variables are called as like terms, and if they have different variables, they will be called as unlike terms. That means if I have example 2x, 3x, 5x, 7 by 2x minus 10 by 3x, something like this. So all of them have same variables, no? X and x, correct? So this will be a group of like terms. That means 2x, 3x, 5x, 7 by 2x minus 10 by 3x, all will come under a category called as like terms. Or if I have like 3x square, 4 by 3x square, 9 by 2x square. Here also x square and x square all are same. That's why this will be one more group of like terms. So 3x square, 4 by 3x square, 9 by 2x square come as one single category as like terms. So these three are like terms, and here all these five are like terms. So like terms means they should have all the terms should have same variables, and opposite of that will be unlike terms. It means it should have different variables. Example, take this one and this one, 2x and 3x square. So 2x and 3x square, are they like terms or unlike terms? They are unlike terms. So you may think here also you have x and here also you have x. So why are they not like terms? The reason is this has square and this does not have square. So you should be very careful. Even the powers that come here, the exponents, the powers that come here, even they should be same. If they are not same, even then they become unlike terms. Okay. So if I have 2xy and 3xy. So 2xy and 3xy will be like terms or unlike terms? They will be like terms because xy and xy are same variables. But if I have 2xy and 3xz. So 2xy and 3xz, can you call them as like terms? Definitely no, because this is xy and that is xz. Even if one variable changes, then they become unlike terms. So like terms have are those terms that have the same variable throughout. Unlike terms have different variables. Okay. Even the powers, even in the variables have same letters, the powers also should be same for them to call as like terms. If the powers are different, then they can't be called as unlike terms. So your homework is try to take any number of algebraic expressions, then make groups of like terms, that is with algebraic expressions with the same variables, and then write down the other ones as unlike terms. So please try to do this homework, and in the next class we will begin with the exercise on the same topic of like terms and unlike terms. Let me know if there are any doubts, and thank you for watching the video.